Trucking right along, 5 videos in a row. Yes, yes, yes. That light's going to go out on me pretty soon, I think. Today we will be able to use the number of moles of atoms in each type of chemical formula, what we just learned last unit, or I'm sorry, not last unit, last video, to determine this gram formula mass. What is the mass of all of this whole compound if I have 1 mole of it? Okay, so first, why gram formula mass? Well, because this molar mass or gram formula mass, notice these are all the same thing. I can say gram formula mass, I can say formula mass, I can say molar mass, mass of a mole. All enable me to count atoms by massing them, which is good because I'm not going 1, 2, 3, 4, 5 atoms. Can't see them. Okay, they're too small. The coefficients, like I said, usually represent moles. They can actually represent anything you want, but grams can never be grams, not the coefficients. And I've said that now on 3 of the 5 videos. So I think that you're getting the point that coefficients cannot be grams. It can basically be anything else. We use gram formula mass to get from moles to grams. Okay? Okay. So let's figure out how to do that. So the technique for calculating gram formula mass. Ready? I count the number of each atom present, which we just learned how to do 2 videos ago, or last video, really, right? Then I multiply that number of atoms by its mass on the periodic table, and I've included a few of those. And then I add up the total of masses for each of those elements in the compound, and I'm done. That is my number, grams per mole. So I have 4 examples. I'm going to work you all the way through all 4 of these, and I'm going to try not to go too fast. I'm going to go slower at the beginning, and I'm going to go much faster at the end. And I want you to see how much room you need to save yourself because I'm going to use up every space underneath example 1, and I'm going to go right up towards example 2. So space out your stuff as best as you can ahead of time. Okay? Ready? Here we go. Example 1, NaF. So I see I have an Na, and how many of them do I have? I got 1. And then I look up on my handy dandy reference table and I see that the mass of Na is the top number, which is 22.98977. And I promised you that this is not honors chemistry. We will just round that, and we will round that to 23. Can we all agree that 22.989 is much closer to 23 than 22? And if anybody needs some help in how to round, please let me know. I've already seen errors earlier on. So in other units, let's make sure we get this right. Okay, we're going to just call that 23. 1 times 23 is obviously 23, so that's nice and easy. Okay, so we got the first piece set, but Na is not the only thing in this molecule. I also have an F. So first I have to know how many, and that's 1, and I need to do that accurately or see how it compounds through. If I can't count the atoms to begin with, we're in a whole lot of trouble. Okay, so, and you can see as the examples go, it gets more and more complicated. Okay, F. So when I look at my handy dandy reference table, 1F weighs 19. We're going to round that right up. And 1 times 19 is 19. And then we learned last slide that I just take those 2 numbers and I add them up. And when I add them up, I get 42. And then I have to put some units on there, and that is grams per mole. That means 42 grams per mole, or 42 grams equals 1 mole. Grams per mole, okay, per 1 mole. Gram formula mass is always 1 mole. That was in a previous unit, or I keep saying unit, previous lecture, and I mean that. It's per 1 mole, so I know 1 mole is 42 grams. Okay, can we speed it up now, Milks, because you're going a little slow. Okay, counting atoms. So first, let me go with mg's. I got a 1 of them. I look up on my handy dandy reference table and say, yo, mg is worth 24 grams per mole. So let me say 1 times 24 is 24. Good, moving right on to Cl. I see there's 2 of them. And I look on my handy dandy reference table, and each one is 35. 0.4 is smaller than 0.5. And if you want to try and round the 4 up to 5 because of that, then you got to look at it as a whole thing. So 45 is less than 50. Got to do it like that. So 45 is less than 50, so I round down. So it's 35. 2 times 35 is 70. Take 24, add it to 70, and I get 94. And then you can't forget, this is the piece, grams per mole. We need that. You can't leave that off. Gram formula mass is always grams per mole. That's a huge deal. That means that we can do some unit analysis things later, and super important. Okay, next one, polyatomic ion. So I'm slightly more complicated, but not much in this particular example because there's only one of the polyatomics. Notice there's not parentheses around it because there's just the one. So still, NA's got no subscript. It's got a mass of 23, and there's only one of them, so that's going to be 23. N's now. I have one N because there's no subscript after the N, and I look up N, and N I think weighs 14. So 1 times 14 is 14. We're doing fabulous so far, right? And then I see, though, that there's 3 oxygens. So oxygen, let me look that bad boy up. He is 16. 15.999 rounds up to 16. So 3 times 16 is 30, 48. Okay, now I'm going to take all 3 of those numbers now and just add those 3 up. And I will get 85, and then I can't forget this piece, grams per mole. It's so important. When I get 85 grams of NaNO3, I have exactly 6.02 times 10 to the 23rd molecules of NaNO3. So per mole, that's huge. So now we're going to be able to get somewhere now that we have this number with those units. All right, last one's a little bit more complicated. And again, counting atoms is the number one thing we need to be able to do. So don't think it's trivial. Don't try to overlook it, because you'll see if you screw up counting here and say there's only one N, you'll be off by 14 in your mass, okay, your gram formula mass. So Ca has no subscript, so it's just 1. When I look up Ca's mass, it's 40. 40.08 rounds down to 40. Good. And 40 times 1, simple math. Okay. Here, though, I have to back distribute that subscript, and I have 2 N's. NO3 twice. So if I write NO3, NO3, notice there'd be 2 N's. Okay, so now I take N, 2 N's, multiply it times 14, and I get to 28. And then I have to back distribute the 2 into the oxygen also, which means I have 6. There's now 6. This is 3. This is 6. 6 oxygens. Each oxygen, again, still weighs 16. You're going to get to know oxygen is 16 quick, I promise. And 6 times 16 is 60, 96 quick. In my head, good, good, good. And then I take all these 3 numbers and I just simply added them up. And I add those up, comes out to 164. Can't forget my grams per mole. And whew, we just accomplished something. This is the first real task, and why we took so long to count atoms, because now we're going to take that somewhere and it is going to compound quickly. Enjoy your practice.